Satish Chand Bansal from South Asian University, Professor Stefano Innamorati from University of L'Aquila, Italy. To all the faculty members, our Honorable Principal Professor Harpreet Kaur, the research scholars and students from various leading colleges and universities in Delhi, to the two-day international colloquium on recent trends in mathematical sciences. Before we begin, may I request everyone to cover their heads and join us in our college prayer to invoke the blessings of the Almighty. Mathematics as an expression of the human mind reflects the active will, the contemplative reason, and the desire for aesthetic perfection. Its basic elements are logic and intuition, analysis and construction, generality, but also individuality. India's engagement with mathematics goes back over 3,000 years. As an ancient Sanskrit verse states, Yatha Shikha Mayuranam, Naganam Manyo Yatha, Tadvad Vedang Shastranam, Ganitam Murgin Sansthitam, which means, like the crest of the peacock and the jewel of the serpent, mathematics stands at the helm of all sciences. The contributions of Indian mathematicians like Bodhayan in the advancement of mathematics through the Sulba Sutras in the 8th century BC, of Aryabhatta and Brahmagupta to the development of algebra and astronomy in the 6th and 7th centuries, of Bhaskaracharya to the learning of algebra and arithmetic through his treatise Leelavati in the 12th century, of Madhava to the field of calculus in the 15th century, and of none other than Srinivas Ramanujan to the field of number theory in the earlier 20th century, are all well recognized and have been a great source of inspiration for succeeding generations. Today, mathematics and its allied fields like computer science, statistics, operational research have acquired an independent identity and have been at the forefront in contributing to innovations in the field of science and technology. In recent years, the influence of mathematical sciences to other fields has grown enormously, and with its myriad applications, it is seen to permeate all fields, be it sciences, economics, finance, or social sciences. Through this colloquium on recent trends in mathematics, it is our endeavor to provide a forum to academicians from all over the world to engage, interact, and discuss the recent developments and advances in different dimensions of this discipline. We hope to emphasize the profound impact of mathematical sciences on improving societal welfare by providing solutions to problems faced by industries, while also inculcating the habit of rational thought, promoting scientific temper, and nurturing mathematical talent amongst our young scholars present today. I am now delighted to take this opportunity to introduce our Honorable Principal, Professor Harpreet Kaur, who has taken out and spared her valuable time to be with us today. And Professor Kaur, a dynamic and charismatic personality, has steered the college towards the pinnacle of success through her dedicated efforts and able leadership. She is an academician par excellence, an able administrator, an effective leader, a keen researcher, and a prolific writer with numerous articles and publications to her credit. She is the recipient of several accolades and awards for her exemplary contribution to the field of women education, such as the Commonwealth Innovation Award for Leadership in Women Education and the Great Indian Teachers Award 2021 by the Lead Global Conclave. It is with great pride and honor that I welcome you, ma'am, and request you to deliver the welcome address today.
At the very outset, I welcome all the speakers who have joined from India and abroad. And the list is very impressive. We have tried to put the best brains across the world in this conclave and the recent trends in mathematical sciences. So this colloquium we have planned so that we know about the experiences abroad and also in India, and so that our students learn a lot from them. And of course, at the very outset, I welcome Professor Sat Gupta, and he's joined from North Carolina. Welcome you, sir. And also we have, through the 2 days, we have participants from various other universities also, speakers from South Asian University, of course, we have Professor Manish Gupta today from Gujarat, and also from Italy and so on, and also Russia and Thailand. Here we want that our students should know that how mathematics and applied mathematics is becoming so important. Sonia has really charted our history, that how in the ancient period, even India, we can say, had the golden period of maths, and whether it is concept of zero or algebra, arithmetic, and so on, it was all there present in our history. And of course, not only that, even if we see Indus Valley civilization, if the town planning was there in that civilization, if the roads were running parallel to each other and cutting at cross sections, all this is an applied part of mathematics. So how the mathematics was used in application in town planning and so on. So this is really marvelous. So we have to delve into these things and understand that how mathematical formulas were used that time also. And if I see, there's one marvel, there's in Puri, we have a sun temple, and that sun temple has been so beautifully made that in the morning, the sunlight kisses sort of the deity there, and at a particular time. So how beautifully and mathematical planning was there in that temple today also, it is a marvel for people to understand. So these things and various things are there as part of the Indian heritage, as part of the Indian history. We have to understand it and of course celebrate it also. But what is required today is that today a lot of changes are coming in the way we work, in the way we are doing things. So we have to understand that trend, that how mathematics is being used as not just one discipline, but that this is a kind of a discipline where if it is applied with other disciplines, it can do wonders. Even computer science for that matter, it is all based on mathematical formula and so on. Or if I see that if we apply this mathematics to accounting or bookkeeping, and or financial modeling, and so all these are based on mathematical applications. So the students doing here mathematics can go into various other disciplines also, and they can be a part of it also, and they can do wonders. So tangible benefit as well as intangible benefits of mathematical sciences are very, very broad. The students must understand that you can make your career in various facets, and you can go into various other parts also. So you have to understand the importance of it. And this precisely this colloquium we have planned so that we the students know about the vitality of the discipline, how this discipline is can contribute to the scientific and technological progress. And this is all to open your mindset and have put on your thinking caps so that you understand that how you can make your career. And for this we have best of the brains across the world. And I thank all the speakers and the participants, and of course my team, including the TIC, Maths, Mandeep, and Sonia is there, then Rama, Rashmi, and all others who are here. And of course the student team who are part and parcel and who have done quite a lot to make this event a success. So I welcome you all, and I'm sure that you are going to have a very, very stimulating discussions and stimulating commentaries during the whole colloquium, and you will learn quite a lot. Thank you very much.
Thank you so much, ma'am, for your valuable words of wisdom and your constant guidance, support, and encouragement, without which we would not have been able to organize this colloquium. You're always a source of inspiration and motivation to all of us, and may you continue inspiring and guiding us in all our future endeavors as well. Thank you so much, ma'am. And now I would like to request our teacher in charge for Department of Mathematics, Mrs. Mandeep Walia, to welcome our guests and the participants of the session.
Good evening, all. I, Mandeep Walia, teacher in charge, Department of Mathematics, on behalf of my department, welcome you all in this mathematical colloquium organized by Department of Mathematics in collaboration with Internal Quality Assurance Cell. My sincere thanks to our principal ma'am, Professor Harpreet Kaur, to spare her valuable time for us and grace this occasion. She is a guiding support for all of us, and she always encourages us to do academic activities. I welcome Professor Sat Gupta, today's keynote speaker, Dr. Jagdish Bansal, and Professor Manish Gupta, who accepted our invitation to grace this colloquium. We all are looking forward to hear from you, sir. And now I also welcome all the participants who are our students who join this colloquium, students, faculty members from our university, from outside our university. So I welcome you all, and definitely you all are benefited or you enlightened by the talks that given by our esteemed speakers. I welcome you all once again. Thank you very much.
Thank you
to Sonia.
Yeah, thank you so much, ma'am. I now request Dr. Lokesh Kumar Gupta, the coordinator for the Internal Quality Assurance Cell, Mata Sundari College for Women, and request him to say a few words.
Dhanyavad Sonia, Madam Principal, Professor Harpreet Kaur, Madam Mandeep Walia, TIC Mathematics Department, Rasmi Verma और सभी organizing team, invited speakers. आप सबका बहुत बहुत स्वागत है। अभी कॉलेज में हूँ अभी भी, और लगातार हम लोग अनेक काम कर रहे हैं, अलग अलग प्रकार के कार्यक्रम कर रहे हैं। हम लगातार इसी तरह के काम और करते रहेंगे। आप सबका बहुत बहुत स्वागत है इस कार्यक्रम में, 2 दिन के कार्यक्रम में। बहुत बहुत धन्यवाद।
Thank you, Lokesh sir, for your support also. IQAC has been organizing, collaborating with a lot of departments and conducting a lot of seminars and FDPs and seminars, FDPs, colloquiums for our college. And Lokesh has been very actively involved. So we thank him also for being a part of our colloquium today. And now it is indeed my privilege and honor to welcome Professor Sat Gupta, Professor and Head, Department of Mathematics and Statistics, University of North Carolina at Greensboro, USA, as the keynote speaker of our colloquium on recent trends in mathematical sciences. He is a fellow of the American Statistical Association and the founding editor-in-chief of the prestigious research journal, Journal of Statistical Theory and Practice, published by Springer. He is a recipient of several awards, such as the Senior University-wide Research Excellence Award and the College of Arts and Sciences Senior Teaching Excellence Award at the University of North Carolina at Greensboro, the Outstanding Faculty Award from the University of Southern Maine, the Distinguished Service Award for the Cause of Statistics given by the North Carolina chapter of the American Statistical Association, and the Sankhiki Bhushan Award from the Indian Society of Agricultural Statistics. He is also the winner of the Aeon Journal Writers Contest for 2016. Professor Gupta has published over 150 journal articles and has several edited book volumes to his credit. He has provided research guidance to students at all levels, from undergraduate to PhD, and received funding from various agencies like the National Science Foundation and Mathematical Association of America, to name a few. He has also given over 150 talks at various conferences, many at international destination, and serves as the general chair of the biennial International Conference on Advances in Interdisciplinary Statistics and Combinatorics, held at the University of North Carolina at Greensboro. Last but not the least, a somewhat unique aspect of his career is that he has successfully applied his knowledge in the field of statistics in providing statistical consultancy to both on-campus and off-campus communities, like researchers from various disciplines such as biology, economics, education, etc., and to biotech companies as a part of industrial consultancy. He has also provided testimony in many court cases as an expert witness. It gives me immense pleasure to welcome you to the colloquium, Professor Gupta, and may I now request you to kindly deliver the keynote address. Megha, have you made Professor Gupta the host? Professor Sat Gupta would have joined. Have you made him the host?
Hello, Megha.
Yes, ma'am. Hello, ma'am.
So, have you made Professor Sat Gupta the host?
Yeah.
1 second, ma'am.
He is the co-host, I can see.
Yes, ma'am.
He is a co-host, right?
Yes, ma'am, he is.
Okay, we can see you now, Professor Gupta. Good morning to you. Can you hear us?
It's good evening,
Yes.
sir, Good morning for you, I think.
Good morning for you.
Good morning for you.
Yes, it's kind of confusing. It's morning here. The sun has not come out yet, and it's kind of evening in Delhi. But I understand the constraints. So a very warm greeting to all of you, all the participants, and a very big thank you to Principal Dr. Harpreet Kaur and Rashmi. Actually, Rashmi's advisor and I were classmates, and we did PhD in Delhi, pretty much on the same topic. But then I moved to USA and started shifting more and more into statistics. So thank you so much for inviting me to give a talk at this international colloquium on mathematical sciences. I'm not sure really what to speak. I just wanted to pick something a little different. I think the title of the colloquium is Recent Trends in Mathematical Sciences. And I think there are two big trends that you may have noticed or you may not have noticed. One is involving undergraduate students in research. Now, of course, that cuts across all disciplines, but it's more so in mathematical sciences. We run a National Science Foundation funded program every summer where all across America we recruit undergraduate students who come to our campus and do 10-week research. And some of the work these students do is just remarkable. It's published in mainstream journals. So that's a new trend. In my time, when I did my PhD, research was a taboo until you become a PhD student. There was no such thing that undergraduate students will do research or master students will do research. But now even high school students have started doing research. So that's a trend that should be embraced. And I think within the college, the professors can take the lead and start involving their students, even in a very modest way, involve them in your research. I think that will be tremendous. And the other thing is collaborative work. I think there was a time when people will work in their individual offices, lock the door and keep working. But that doesn't happen anymore. Earlier, papers were published, which was single author, maybe two authors. But today, you will see papers very commonly with 3, 4, 5 authors. Some of the papers may actually have 100 authors on the same paper. Papers published in Nature, papers published in Science have a lot of authors. So I think collaboration is the way to proceed and give up the whole confidentiality or privacy issue, and reach out to others and start working with them. The topic that I chose today, it's on statistical consulting. And consulting happens in all disciplines. Lawyers consult, doctors consult, well, statisticians also consult. You may find it hard to believe that most statistics professors, they carry a private consulting practice, just like the doctors have a private consulting practice. Statistics professors also have a private consulting practice. And I'll share with you some of my consulting projects. In many cases, the consulting income actually is more than their salary. So, but it's just that people don't pay too much attention to this. And it's not just a money-making or make extra money sort of a thing. No. When you involve statisticians in your research, these days everybody generates data, whether you are doing research in biology, physics, religion, political science, you name it. Data is everywhere. And when you have data, you do need a consultant, a statistician who can help make sense out of that data. So that's why I chose this topic, that this may be somewhat of a new topic. Pardon me, my throat is not all that great and I'm just waking up. I have had my second cup of tea, but it's still going to take some time before I feel normal. So let me share my screen with you. So as I was telling you, that the topic I've chosen today is statistical consulting in the real world. Now, there are a lot of videos available on statistical consulting. There are books available on statistical consulting. But what I'm going to talk to you about, it's about some real statistical consulting cases that I have handled myself. So these are not, it's not kind of a abstract topic. These are real things that I'll be sharing with you. Now, the question is, what is statistical consulting, and what do you need in order to practice this thing, statistical consulting? Well, first of all, there should be early exposure to data, data analytics, and statistics. Data is all around us, but we don't realize the significance of data. So there should be some exposure to data as to what is data, how do you handle data. If nothing else, at least you should know how to organize data. You should be aware that sometimes people can cheat with data. They can create graphs which look very misleading. So that kind of exposure to data is very important. And it should happen fairly early on. A very important part of statistical consulting is that you should learn the art of converting a word story into a number story or a statistical story. And this is where actually this whole thing begins. I'll give you one example. About 5 years ago, a high school student came to me and said that, "Uncle, can you help me with my research?" And I said, "What's your research?" And this girl said that, "Uncle, I'm trying to prove that girls are more good looking than boys." Now, that's her story. Girls are more good looking than boys. It's a word story. Now, how do you convert this into a statistical story? And what it means is, how do you quantify good looks? Now, if I can quantify good looks, then I'm in business. So you can find out the level of good looks for boys and level of good looks for girls based on a random sample, and then you can do it. So the question is, how do you quantify good looks? And there are various ways of doing it, but one way that this girl was doing was to find the golden ratio. And the golden ratio was the distance from the top of the head to the chin divided by the two cheekbones, the distance between them. And larger the ratio, higher the golden ratio, and more good looking you will be, which in essence means that somewhat longer faces are more attractive than round faces. But again, this is not my theory. This is what the general theory is in terms of golden ratio. It applies to buildings, it applies to people, it applies to sculptures. So once this girl was able to calculate golden ratio for a random sample of boys and random sample of girls, it becomes a very simple problem. Then you can compare those two means, you can do regression, you can do different things. But the key was, how do you convert a word story into a statistical story? I'll share with you a consulting project on which I testified in a court. And the case was that somebody brought forward a lawsuit in a court that I have been discriminated against based on my age. So discrimination based on gender, based on color, based on religion, based on age, these are very common. So how do you deal with that? And in order to deal with that, you first need to convert the story into a number story. And once it becomes a number story, then it gets into your domain. And then you can apply your statistical knowledge and try to find a solution to the problem. Now, what else is needed for statistical consulting? Well, you need a course on statistical inference. Even if you leave out the word inference and just call it a course on statistics, that's enough. So that way you get some structured knowledge of statistics. I'll tell you one personal thing, that when I did my PhD in mathematics from University of Delhi and became a lecturer first at Shriram College and then became a lecturer at Sri Venkateshwara College, I had very little appreciation for statistics. I thought that these guys are all bogus because you always talk about, I'm 95% sure. Well, the question is, what about the other 5%? There's no such thing in mathematics that the professor gives you a quadratic equation and you find a solution. And then you try to tell the professor that my answer is 95% correct. Now you'll get a 0 on that problem. But in statistics, that's the way things happen. So I didn't realize, and it was my ignorance, that in spite of that 5% room for error, statistics is a great subject. So you need to understand that. You need to also understand the difference between statistical significance and practical significance. Sometimes some evidence could be, statistically speaking, very significant, but it has no practical value. Or the other way around, it is very significant practically, but it does not add up to statistical significance. So the difference between those two is an important thing. If you're serious about making a career about, around statistical consulting, then you take a course on statistical consulting. There are a lot of online help that's available these days. Most universities in America, they will teach a course on statistical consulting. We actually have 2 small courses, a 2-credit course and a 1-credit course on statistical consulting, the art of consulting. So that also is important. Now, let me give you a simple example to get things rolling. Anecdotal evidence versus statistical evidence, or practical significance versus statistical significance. So suppose I have a situation where there are 4 jobs and there are 40 applicants. And out of those 40 applicants, there are 20 men and 20 women. So 40 people applied for the job, 4 jobs, right? Now, and let's assume that they're equally qualified. Now, if there are 20 men, 20 women, then ideally these 4 jobs should be distributed equally. There should be 2 men who should be hired, 2 women who should be hired, right? So 2-2 split will be perfectly normal. There'll be no eyebrows raised. There'll be no concerns expressed. But let's look at it from a statistical perspective. Now, before I get into this, you need to know a very important thing in statistics called p-value. And p-value simply is the probability of seeing what you saw just by chance. That is, what you saw, could it have happened just by chance? Was it a fluke? Or is it something real that made it happen? So if the p-value is very small, that means this thing could not have happened just by chance. It's not fluke, it's a real thing. So small p-value makes the findings very significant. Large p-value makes the findings insignificant. So even if you have never heard about p-value before, this is all you need to know. In statistics, people live and die with p-value. Computers will calculate the p-value for you. So p-value is the probability of seeing what you have seen just by chance, okay? And small p-value is the indicator of significance. Now look at the problem, 4 jobs, 20 men, 20 women. Now, what if 2 men and 2 women are selected? You don't need statistics. I think you can tell based on common sense that that's perfectly normal, right? But let me try to find out the p-value for this outcome. What's the probability that 2 or more men were selected? Remember, I told you p-value is the probability of seeing what you saw or even more extreme finding just by chance. So the p-value for this, and you can apply some binomial distribution, hypergeometric distribution, the p-value comes out to 0.698. What does it mean? Well, that means 2-2 split. There is a 70% chance that something like this could have happened. So what's the big deal? This is perfectly normal. What if there were 3 men and 1 woman selected? Well, it begins to look a little suspicious now. That why this split was not 50-50, why there were 3 men and 1 woman. But the p-value for this is 0.302. So there's a 30% chance even this could have happened. And therefore, still there is no big deal. The typical threshold for significance is 5%. If the p-value falls below 5%, you begin to attach significance to it. 30%, well, it's a fairly large p-value. This is a common occurrence, it can happen. Now, what about this, the highly suspicious thing? What if all 4 men were selected, no woman was selected, there were 40 of them, 20 men, 20 women, no woman was selected, it's all men. What's the probability of something like this happening? A little more than 5%. Now, if one of the women among the applicants brings a lawsuit in a court that I have been discriminated against based on my gender, the court will say, lady, the probability of something like this happening is more than 5%, and 5% is the typical threshold. Chances are the case will be thrown out. So at a practical level, this looks suspicious. But at a statistical level, this is not suspicious. This is something fairly common. It can happen. So I'm saying that there's a hint of gender bias here, but this hint does not cross the legal limit of significance. So basically, this kind of a calculation statisticians will do. They will evaluate the strength of the evidence. And that evaluation happens typically through p-values. Now, it doesn't have to be only like legal cases. A biologist or a chemist is doing some lab experiment, is expecting to see something different from normal. And you collect data. And you can say that earlier, let's say the average reaction time would be 3 minutes, but now the average reaction time is 2 minutes. So the question is, have things changed significantly? 2 minutes today versus 3 minutes earlier, is it a big difference? Well, again, you can do a statistical test and try to find the p-value. If p-value is less than 5%, you say yes, it is a significant change. If the p-value is more than 5%, then it's not a significant change. Now, where do we get these kinds of problems? It all comes through our Statistical Consulting Center. So every university, almost every university in America has a Statistical Consulting Center, but it's not very common in India. I've been coming back to India for the last 35, 40 years, and every time I come, I always advocated, please set up a consulting center. You can do that in your own college. Somewhere in one faculty member's office, put a desk and put a note outside that this is our Statistical Consulting Center. Now, I may be off here. I'm talking to mathematicians. I don't know if there's a separate department of statistics at Mother Sundari College or not, or statisticians and mathematicians, they live together. But this advice is mostly for statistics people, that you can set up a consulting center and start helping the college community, start helping students. So that should happen. So our encounter with these kind of projects, they come through our students and faculty on campus. As I was telling earlier, that I have consulted with the faculty from many different departments, as broad spectrum as political science, religion, music, nursing, economics, public health, so many different faculty members doing research in their individual areas. They will come over and seek help. And I'm not the only one. All these stats professors, they are available to provide consulting to students and faculty engaged in research. As far as the off-campus clients are concerned, sometimes some company will call you and seek your guidance. So you can go to their office and provide some guidance. Sometimes you end up writing a report, and that report is then sent to regulatory bodies. For example, Food and Drug Administration, EPA, Environmental Protection Agency, USDA. So there are issues going on, and there are some concerns. So they seek your help. You write a report, and I'll share with you one such example. And the most challenging one is where you represent a client in a court case. And statistics professors end up doing it fairly frequently. Now, when you're preparing a report for regulatory bodies, it's important that you read the protocol very carefully as to what the rules of the game are. And the rules of the game are not written by God. The rules of the game are written by human beings, and they can make a mistake. Just because it's in the rules doesn't mean that it's correctly written. It can be challenged. So if you feel that something needs to be challenged, you do so, but do so respectfully. And remember that the work you are doing has a big significance for your client, because the future of the client, reputation, product, it all depends on the quality of your work. Representing a client in a court case as a statistical consultant, this is something very serious. The very first thing I'd like to advise here is that never lie. Now, this may come as a shock because when you watch Indian films or hear stories, they always talk about कि भाई कोर्ट में तो झूठी झूठ होता है, सच तो कुछ होता ही नहीं है. लेकिन अमेरिका में if you lie under oath, you go to a courtroom and you are put under oath and you lie. वो तो इंडिया में भी होती है कि आप गीता पे हाथ रख के कसम खाते हैं कि मैं सच बोलूंगा, सच के सिवाय कुछ नहीं बोलूंगा. यहाँ पे भी होता है ऐसा. लेकिन यहाँ पे one thing is very simple, that if you lie under oath, you are going to jail. Forget. There's no other alternative. You lie, from going to jail. You can keep quiet. You may refuse to answer, but if you answer untruthfully, that's big trouble. So never lie. This is what I teach my students, because they eventually at some point in time may become a consultant, may get called in to work in a court case. So don't do that. Don't carry unnecessary papers with you in a courtroom, because the discovery process, I think that's true in India also, but in America, discovery process is very, very serious. You need to share with the other side whatever work you have done. So if you take a bag with you, it is quite possible they may ask you to empty your bag completely and see if there are any papers, your scratch notes, where you have written something which seems to support the other side. It's important. Learn about courtroom etiquette. For example, when you go to court, you should be properly dressed. You should call the judge as your honor, and so on. So it's important. Do not speak too much. Some people, they like to just talk and talk and talk. But in a courtroom, more you talk, more trouble you are inviting for yourself. Just keep your responses very limited and very pointed. Try to speak to the judge or the jury once you have heard the question from the attorney. So attorney's job is to ask you a question. Once the attorney has asked you a question, ignore him or her and turn your chair toward the judge and talk to the judge and explain the finding to the judge. You are in that way connecting with the judge more clearly. It's very normal for the attorneys to get under your skin. They try to insult you. For example, in my very first case, I used to charge $100 per hour, and the other consultant, the other professor, was charging $500 an hour. And they knew that, because as part of the discovery, they knew that. But they'll ask you in court that, Professor, how much money are you making per hour? How much do you get paid? And they're trying to insult you that, look, the other professor is making $500. You're a cheap guy. You're making only $100. But it's okay. Sometimes they'll say that, well, you have never taught this. What makes you think that you are a competent consultant? These kinds of things happen. So there's no need to get upset. Don't speculate on anything. If you know something, then say it. Otherwise, you just say that I don't know the answer. And keep some tricks up your sleeve just in case the other side opens the door for you. One of my consulting cases I'll show you is an example of this. What happens is that in a court case, you cannot all of a sudden start talking about something very different. It has not been discussed with the other side. And you start bringing in that discussion into the, that sort of evidence into the discussion, and you're not allowed to do that. Unless the other side begins that discussion. So if they are the ones who started the discussion in that direction, then you can jump in. But on your own, you cannot do that. So if they open the door for you, then you can go in. Otherwise, no. Now, before I start sharing some of these examples with you, and whenever the time is up, just let me know and I can stop. And there are 3 examples that I would like to share with you. And I don't know how far I will be able to go. But within our department, our combined department, mathematics and statistics, but we have deep collaboration with biology. There is the subject called mathematical biology, where we and biology department, we collaborate. We've gotten a lot of research grants in collaboration with biology. So that's an example of going outside of your department and then doing things. Within mathematics, actually, I always thought that topology was one of the purest of pure mathematics. But today, there is this whole field, topological data analysis. So you can bring in a lot of statistics into topology. There is this thing called computational topology. And so even the very pure math topics, statistics can be involved in those topics also. It's just a matter of taking a peek outside as who else doing what. And then you can maybe start collaborating. Now, let me give an example. As I said, I'll give you 3 examples. This one is where it never went to court, but our fight was with FDA, Food and Drug Administration. In America, there are 2 agencies you don't want to take. So FDA is one, and IRS, Internal Revenue Service. So these two agencies are graded agencies. People that don't, take too many liberties with them. And we, in one case, had a big fight with FDA, and I thought I'll share that with you. Anytime there is a test that's created, like for example, these days everybody's talking about COVID. So there's a test for COVID. So you go and subject yourself to a COVID test, and then the result will come either within a few minutes or within a day, depending on what kind of a test you're doing. But a test is a test. No test is foolproof. The test might say you have COVID, but actually you may not have it. Or the test might say you don't have COVID, but actually you may have COVID. So there's always this thing, false positive. There's always such a thing as false negative. Typically, false positive should be small. False negative should also be small. So there's this thing called sensitivity and specificity. And for a given test, what is sensitivity? Is the probability of a positive test if the sample is contaminated. Namely, if the person really has COVID, the COVID test should come out positive. So the probability of that is called sensitivity, how sensitive your test is. And specificity is, if you don't have COVID, your test should come out negative. And if the FDA protocol is that for a test to be approved by FDA, sensitivity should be at least 90%, specificity also should be at least 95%, and you should be at least 95% sure about those findings. So that's what the protocol is. And this is about milk testing. This particular case was about milk testing. In India, typically you do milk testing that if the dairy owner has put water in the milk. But here, the concern is not if the milk is too thin or diluted. The concern is if there is any drug in the milk. Now, why should there be any drug in the milk? Well, if the cow gets sick or the buffalo gets sick, well, there's no buffalo milk here, there's cow. So if the cow gets sick, you treat the cow with penicillin or amoxicillin, and for X number of days, that milk should not be sold. But if you're greedy and you actually milk the cow and sell the milk, then that milk can have traces of penicillin in it or traces of amoxicillin in it. So there are test kits. So before the milk is sent for human consumption, you test it and make sure that there are no traces of drugs in that milk. So there's this company I used to do consulting for, and one of their products was failed by FDA. FDA said that you don't meet this protocol, particularly for the sensitivity. And so the question is, the product is now failed. And it's a huge loss to the company. There's a loss of reputation also. So this is where the story started. Now, typically what happens is, this is the old way of doing business. These days, it's not done in this fashion. So let's say you prepare 20 samples where they are definitely contaminated. And they're mixed with uncontaminated samples. Then you ask a technician to apply that test that the company has manufactured and see how many of these 20 will be caught. And suppose it turns out that all 20 in blind testing were caught. So the sensitivity is 100%. Your test kit was able to catch all of them. So is this the end of the story? 100% sensitivity. FDA's requirement was only 90%. You are at 100%. Are you done? Remember, the other part was not only it should be 90%, but you should have enough confidence about these findings. And so you find the same old p-value. And the p-value is what you saw, could it have happened just by chance? If the actual sensitivity was less than 90%, could you have seen something like this just by chance? And the p-value comes out to be 12%. That means that this kind of a finding could have happened more than 12% of the time just by chance. Therefore, this is not impressive enough. Your test is not impressive enough. If you had played the same game with 30 samples and all 30 were caught, the p-value now is 0.0424. Therefore, the probability of the results being so beautiful just by chance was less than 5%. That means this could not have happened. Therefore, your test kit is fine. It should be allowed to be marketed. So this is how we used to do business earlier, but then things switched to a more continuous scale. So rather than preparing samples only at the the threshold level, like for example, for amoxicillin, 10 parts per billion is considered dangerous. So earlier, we would create samples only at 10 parts per billion, but now the testing is done with clean samples, small amount of drug, a little bit more, a little bit more, a little bit more, and then the dangerous level 10. And look at this. At 10, you get 29 out of 29 they were caught. At 0 out of 60, nothing came out positive. So specificity seems pretty good. Sensitivity also seems pretty good. But the question is, you are not looking at just one single value. You are creating some kind of a dose response curve and then find the answer based on this. So according to the FDA, these data indicated to them that the product is not good. So the product was rejected by FDA. And that's where I got in. Now, what you do for these kinds of cases is you try to create sensitivity and a confidence interval around it using a dose response curve. If you simply use 29 out of 29, 100% sensitivity, right? Now you cannot create a approximate 95% confidence interval for it because there will be some mathematical breakdown. In the denominator, you'll end up with a 0. And therefore, that method will not work. So you need to get what are known as exact confidence intervals rather than approximate confidence interval. Now that's another thing. If you are in a hurry or you have very limited knowledge of statistics, you will say that, well, let me create this routine confidence interval that we teach in our courses, and you will not know what the exact confidence interval is, but that's what you need to do. And it turns out that when I do the 95% exact confidence interval, my lower limit is 0.902. Well, that means the FDA requirement is met. So why did FDA reject this product when it's being met? Well, again, the problem now is that you are not utilizing a dose response method. You are simply concentrating on one level, 10 parts per billion. So what the FDA was doing was, there are various models of testing it. FDA said, well, everybody should be using a model called probit model. And if you don't know what probit model is, it's okay. Just imagine that there is a statistical technique that FDA was asking everyone to follow. And according to that technique, the sensitivity lower limit came out to 0.8729. Now, what does it mean? You're below 90%. And therefore, FDA rejected your product, right? I always used to use logistic regression. That is a different method. FDA was using probit. I was using logistic. And my sensitivity came out to be 0.8975. So it's almost meeting, not exactly, but you can see that it's like almost 90%. But if you use yet another method called the Gompertz method, the sensitivity is 0.9375. So the compliance is met, right? So the question is, FDA is saying, use this. I always use this. But then when we started discussing this, I thought that I should be looking at a variety of other models also. And we found that using Gompertz method, the test kit passes. So the argument with the FDA was that, how do you decide which model to use? And this became a huge issue. And then finally, I was able to convince them that try to also find out the goodness of the fit. The model that you're fitting, how good is that fit? And it turns out that the best fit was provided by Gompertz model. And therefore, final decision should be based on this, rather than based on the arbitrarily, decided probit model. And actually, the sophistication in this work was very, very little, but it changed the whole protocol of milk testing in the United States. Today, nobody says that use probit model all the time. What we do is we have a suite of 5 different models that dairy owners use, and whichever gives the best fit, take a decision based on that. Now, let me also give you one more example. This is a age discrimination lawsuit. And there was a company where there were a total of 183 employees, and out of those 183, 5 employees were laid off. There was this guy, 62 years old, and the other 4 who were laid off or who were fired these are the ages. So 5 people were laid off and 178 were not. So out of these 5 who were laid off, there's this engineer who was 63 years old. He sued the company. And he said that I have been let go because of my age, not because of my credentials or not because of my quality of work. So how do you now make a case? And this was an actual court case where I testified in the court all day long. So what do you do? Well, first I looked at the average age of those who were laid off and the average age of those who were not laid off. So in the laid off group, the average age was 53. Those who were not fired, their average age was 45. So there's already a hint that it's the older people who were targeted. But the question is 53 significantly more than 45? In mathematics, 53 is always more than 45, no question. But in statistics, 53 is not more than 45 every day. Some days it is, some days it's not. It all depends on that p-value that I talked about. It also depends on how large the sample was. So the question is, statistically speaking, is 53 more than 45? Now you can do that using variety of method. There's a t-test. If you don't know, it's okay. Think of this as a procedure. Here's another procedure. So there are 2 different ways you can do it. And when I do a t-test, and there's a 2-sided test, there's a 1-sided test. Now that's an important part of this whole story. A 2-sided test will test whether 53 and 45 are same or different. That's a 2-sided. But 1-sided will be when you are very specific that 53 is more than 45. You are talking in one direction rather than in 2 directions. If you have the 2 means, are the means equal or not equal? That's 2-sided. Is this mean higher than this mean? That's 1-sided. And so I was just trying to not give the other side some hints ahead of time. So I reported a 2-sided p-value for a t-test, and that was 0.20. And I told you that anything less than 0.5 is significant. So I argued that there is a significant evidence that 53 was different from 45. They are not similar. Now, the other side, they did their calculation based on my report. And they first argued that t-test is not appropriate here. You should be doing a different test, Wilcoxon-Rank-Sum test. Again, no need to know what it is. It's just a different way of doing business. And they found that the p-value was 0.58. And they were kind of happy with that. And they said that, well, Professor, the t-test is not a good test here. Wilcoxon test should be used, and the 2-sided p-value is 0.58. And that's when they opened this door for me. And I said, well, I have also done the Wilcoxon-Rank-Sum test, and my p-value is not this. My p-value is 0.29. Because I'm not doing a 2-sided test, I should be doing a 1-sided test. So that became an important point of discussion, that my client is not saying that 53 and 45 are different. My client is saying 53 is higher than 45. And therefore, I should be doing a 1-sided test. And 1-sided p-value will be roughly half of the 2-sided p-value. So that's where they kind of lost the case. They got into their own trap. I could also do this using logistic regression, where you can see that what's the probability of somebody being laid off based on the age. So you can fit a model, and then you can find out if age was a significant predictor or not. And my p-value for age was 0.28, again less than 5%. So that was a significant predictor. And this is where the other side lost their case and we won the case. So again, using a statistical consultant, helped in this particular case. Right now, actually, I'm working on another case very similar to this. Somebody was let go or fired from a bank, and we are making similar arguments. I don't know when the case will actually end up in court, but if it does, we will be ready. And I showed in the court this graph. This shows that as the age is going up, what's the probability of the person being fired? How is that behaving? And this visual actually was pretty significant. And the judge and the jury could see that as age is going up, the risk is becoming. Well, I think my time might be up. So I may stop my discussion here. There was one more example I wanted to share, but roughly it's the same thing. So let me actually stop the share and open this for discussion, any questions and answers that anyone has for me. But again, remember, the main idea I'm trying to promote here is that statistical consultancy is extremely important, and not only like in public dealings, this becomes important, but it's important even for on-campus research. If you can help people from other departments when they are generating data, you can try to help them. So this is something fairly common in American campuses, but very uncommon in India. I see Gurpreet Kaur is one of the attendees here. I don't know if the same Gurpreet who is at University of Delhi. I think if so, she would be in statistics. So, but regardless of that, I think the point I'm making is reach out to others and see how you can help them, how you can collaborate with others.
So that's it. One question.
Let me stop here and see if anyone has any comments or questions for me.
So we have one question in the chat box from one of the participants. Narsid would like to know if you think statistical tools would be replaced by artificial intelligence and IoT devices in the future.
Well, the artificial intelligence actually is not my area, but there's a lot of stuff that's going on in artificial intelligence. We have a department, computer science department. They are the ones who deal with that. There are a lot of codings that's involved in it. But again, that's not my area. People these days apply artificial intelligence. There was this video from Google where you can call a number and you're not talking to the person, but you're making an appointment for a haircut. And the person on the other side is understanding what you're asking and is able to set up your appointment. Similarly, you want to book a taxi or you want to do something else. So things can happen. There is this question in the chat box about computational topology. I think you'll have to Google it, but if you Google topological data analysis, this is a very new field. I think it started happening in the last 5 to 10 years. And some of the topologists in our department who earlier had very little market value, believe it or not, in America, professor salary does not, it's not same across all disciplines. In Delhi, everybody makes the same salary, you are in a state. But in the United States, the salary for pure math professors is much, much lower than salary for statisticians, and that's much lower than salary for computer science professors. So these topologists earlier, they were branded as pure mathematicians, but those of them who have converted into computational topologists, they are in big demand now. Medical companies are hiring them actually because topology is basically an understanding of features. And they quantify those features and they are able to use statistical technique in taking decisions. So I cannot point you to a particular book on topological data analysis or computational topology, but if you Google it, you can find plenty of sources.
All right. So if there aren't any more questions, I'd like to take this opportunity to thank Professor Gupta. So thank you so much, sir, for sharing your valuable insights into the interesting field of statistical consulting and in making us aware of some of the opportunities and challenges which are encountered in this field. Some of the real-life examples in statistical projects of yours, which you discussed and presented in your talk, have further helped us to gain a better understanding of this topic. Also, we would like to express our heartfelt thanks to you, sir, for accepting our invitation and accommodating the time difference for us and agreeing to deliver the keynote address, even when it was so early in the morning for you. And thank you once again, sir, for sparing your valuable time and being a part of this colloquium. We are indeed indebted and grateful to you, sir, for waking up early in the morning and with your tea you started our session. But it was definitely worth it, and I'm sure the participants would agree. We would have loved to host you if times were better and you were traveling to Delhi. We would definitely host you once again in Mata Sundari College whenever you are visiting. So thank you. Sir, now I request Dr. Amita Sahani to welcome and introduce our next speaker for the day.
Well, thank you very much, Sonia and everybody else. It was a pleasure to be part of this colloquium. Thank you very much for the invitation. Bye-bye.
Thank you, sir. Bye-bye.
Thank you, Sonia ma'am. I take this privilege to warmly welcome Dr. Jagdish Bansal. He is an associate professor at South Asian University, New Delhi, and visiting faculty at Maths and Computer Science, Liverpool, Hope University, UK. He is the series editor of the book series Algorithms for Intelligent Systems. He is the editor of many reputed international journals like International Journal of Swarm Intelligence, IEEE Access, and ARRID. He is the steering committee member and the general chair of the annual conference series SOCPROS. His primary area of interest is swarm intelligence and nature-inspired optimization techniques. Recently, he proposed a fission-fusion social structure-based optimization algorithm known as spider-monkey optimization, which is being applied to various problems from engineering domain. He has published more than 60 research papers in various reputed international journals and has supervised several PhD theses. It is a great pleasure to have you with us today, sir. The topic of the plenary talk is computational intelligence, which is one of the most sought research fields of the time. I request Dr. Bansal to please begin the session.
Thank you, Professor Amita. Thank you, Professor Rasmi and Professor Sonia, for this opportunity to speak here. Today's topic is the computational intelligence, and I hope my screen is visible. Is it okay?
Yes, sir.
Yeah. So, as Professor Amita mentioned, that it's a requirement of the time. It's a very one of the most sought area of research and the development at the current time because of its wide applications in different engineering domains. Today, I'm not going to share let me just adjust all these things. Today, I'm not going to explain you the algorithms in the field of computational intelligence, and I'm not promising that after this 40-minute talk, you will be the expert in computational intelligence, but I promise that you will be aware of the word computational intelligence, what it is, and what kind of algorithm are included in this, and what are the possible applications of this. Is it a topic to explore for your research or not? You will be able to decide it. Of course, you people are the researchers, professors. So once we can remove this inertia of understanding a particular subject, of course, we can explore the subject by ourselves also. So I'll start with the formal definition of computational intelligence. Then I'll discuss the various types of computational intelligence algorithm, the classification of computational intelligence-based algorithms. I'll concentrate, since I'm a student of swarm intelligence, so I'll concentrate more on swarm intelligence-based algorithms. However, I will discuss few in the field of evolutionary algorithm also, which is another category of computational intelligence. I'll discuss then some successful stories of the application of computational intelligence, and then I'll tell you that what is the future of computational intelligence. I'll try to make this talk crisp, So will not go in deep of each and every term, which you can during the lecture you can note down and can further explore through various internet sources. If not found, no worries, you can visit my web page also. Just Google my name, you will find my web page. I have uploaded so many sources related to this, or you can drop an email to me, I'll give that, right? Okay. So formally speaking, the word computational intelligence means the study of the design of intelligent agents. In the computational intelligence, we study how to design an agent which is intelligent. Now, intelligent means what kind of intelligent? Intelligent like humans, intelligent like birds, or intelligent like fish, or intelligent like my mobile? What kind of intelligence? So it depends upon the application, that where we want to apply our agent, what kind of problems we are planning to get solved by this agent. Accordingly, we made that intelligent. For example, my parents thought that my son should be a professor, or my son should be this particular. So accordingly, he sent me a college, university, or the PhD, or whatever. Or I thought it in myself, by myself. But we, the human beings, are also not intelligent in general, right? We are not general intelligence. We are intelligent for a particular area. For example, I know swarm intelligence more as compared to the subject, other subjects that you people know. So you know more in that particular subject of which you are the expert. Similarly, the artificial agents are also expert to solve a particular kind of problem. So similarly, we are doing here, we are making agents intelligent, and these agents are actually artificial agents. The computer program actually it's a computer program which is intelligent in itself. So how to make that computer program intelligent? Of course, there is a certain algorithm behind it, and that class of algorithm is actually the computational intelligence. So computational intelligence, in other words, is a class of those algorithms which make a computer program or a machine intelligent, right? So you may say that machine learning algorithms are also the part of computational intelligence. Now, I already told you that agent may be anything. It may be a computer program, it may be a machine, or it may be some mobile, aeroplane, humans, anything may be intelligent. What is the definition of intelligence? What are the properties which makes an agent an intelligent agent? So actually, before we develop an algorithm, before we think of an algorithm which makes an agent intelligent, we need to define properly that what actually we want in terms of intelligence. So we want these four properties which I listed here. We want these four properties which defines the intelligence. It is not necessary that only these four properties you want to include, but in general, most of the computational intelligence algorithm requires these four properties. If you want, then you can think of including some more properties also for a particular super intelligent agent. If you want to make, then you can include some more properties also into this and can modify your algorithm, customize your algorithm accordingly. However, in general, computational intelligence based algorithms are based on these four properties. Via computational intelligence, actually, we are inserting these four properties to a machine or to a computer program. And after inserting these machines to a computer program, we can expect the intelligence from that machine, right? So what are these properties? The first property is whatever it does is appropriate for its circumstances and its goals. Intelligent agent, whatever it does is appropriate for its circumstances. Like I'm a professor, I give lectures, it is good for me. And if somebody calls me for some other job, for example, drive my car or drive my truck, I will deny. No, I will not drive your truck. Even if you will give me more salary than my teaching, then I will not accept that truck driving, because that's not my job. I'm not expert in that. I'm not interested in that actually, right? Because I know that this is my job. Teaching is my job. So I'll accept the assignments related to teaching and research only. Another is It is flexible to changing environments and changing goals. The very important feature of this, that it is flexible. If the situation changes, for example, suppose there was this pandemic, Corona came. I never taught online. I never gave these kind of lectures in this way. Of course, when I was in BITS planning, I gave 1 or 2 lectures, but those online also, but those were actually recordings, but not live lectures. So now the situation changes, and you believe me, I was the first who started online lectures in my university. Just after the lockdown, I proposed that, okay, let's start with online teaching, and this online lectures, and soon within 1 week, every faculty of my university came to online teaching, and now they are very comfortable. Actually, in fact, they want at least 1 day in a week we should continue the online teaching throughout the semester, even if it is offline. So the humans are flexible to changing environments. That's why we are surviving, right? Similarly, we need to develop this property into a machine also, that if the goal changes, if the environment changes, it should change its goal. It should change its approach. The third property is that it learns from experience. The machines, the junior professor gets less salary, senior professor gets more salary, because it is expected that the senior professor knows more. He has more experience, so he has more knowledge. That's true, actually. So because the humans learn from experience, nowadays the machines are also learning from experience. This machine, when I bought this mobile, my name is Jagdish, I was typing JA, it was not predicting Jagdish. But now I type JA, it is, the first word it predicts Jagdish. However, I have not fed it into it. But after so many times, so many repetitions of the word Jagdish, when I start JA, the machine learns. It is called deep learning, or there are many algorithms actually. I'm not going to take that only this is the algorithm, but nowadays this kind of learning is through deep learning actually. Particularly these mobiles nowadays are enabled with deep learning. So the machines are learning. The first time when I brought that Google Home, it was not comfortable to understand my voice, with that immediate understanding. But after a few days, it started to understand, and it was giving me the results appropriate, whatever the appropriate for me. So the machines are also learning from experience, and this experience is coming from the data. More the data the machine have, more the machine will become intelligent, right? And how to make that data useful to make the machine intelligent, we have the computational intelligence algorithms. Another fourth property is that it makes appropriate choices. The machine should be able to decide that if more than one paths are available, if more than one choices are available, then it should not hang itself. It should not hang. It should be able to decide that, okay, in which path I should move, what is good for me, what is better for me. For example, the humans, if you make me the Prime Minister of India or the President of India, I should be able to decide that which post I should take, right? So, and then I will decide that which post I should take. Similarly, the machine should also be able to decide that which is the good way. So means they should be able to make the appropriate choices. So once we can introduce these four properties to some computer program, we can expect certain kind of intelligence from that computer program. And that intelligence is known as the computational intelligence. Why we call that computational intelligence? Because all these four properties to a computer program or to a machine are inserted through iterative computation. It is not a matter of fact that you just take some data and just put into some computer program and it will become intelligent. No, you need to make that computer program iteratively intelligent. Not in one day the computer program can become intelligent. Of course, sorry, not one day means one iteration. So iteratively, you need these computer programs becomes iteratively intelligent. lot of computation you do with that machine, lot of computation you do with that computer program, and accordingly that machine becomes intelligent, or computer program become intelligent. And that's why this intelligence is obtained through intensive computation, and that's why the computational intelligence, the way by which we can insert these four properties to a computer program, is iterative computation. Through intensive computation we can include that, and therefore the intelligence that is obtained through this is known as the computational intelligence, right? So this computational intelligence, let me tell you, a big word, is an umbrella word. So a lot of algorithms are there, variety of algorithms are there, and also let me tell you that I cannot absolutely classify the algorithms in the category of computational intelligence, because it's an upcoming subject. Every day people are developing new technologies to make the machines intelligent, and so I cannot say that only these kind of algorithms are into computational intelligence. I will just name these are, but not limited to, right? So I will just say that broadly you can consider swarm intelligence, evolutionary computation, and artificial neural networks into the computational intelligence. You can of course keep the machine learning algorithms in the same category. So this is a broad classification of the CI techniques. And when I say that which subject you are studying when you are studying the computational intelligence, I say that you are studying artificial intelligence, because you are making an agent, a computer program, a machine intelligent artificially by inserting some data into it. So artificially you are making that intelligent. The humans are, it's a very controversial statement that we are intelligent by nature. The humans are naturally intelligent. Actually, yes, for the day-to-day activities, we are naturally intelligent. That, if somebody is, healthier than me, and he has more power than me, and he is abusing me, then I should be enough intelligent that I should not respond to this man. Otherwise, right now he's abusing, and otherwise he'll start beating me. But if, according to the situation, we understand that we are to speak, we are not to speak. This is a natural intelligence. But the swarm intelligence, lecture on swarm intelligence, is not natural intelligence. Actually, it's an artificial intelligence. My teachers taught me. I learned it from many books. The other researchers wrote there, and I made myself intelligent in swarm intelligence. So I don't think that it is natural intelligence. It is also some kind of artificial intelligence. I want to say you that any machine where the artificial intelligence is obtained through iterative computation, through many intensive computation, that particular kind of artificial intelligence is called the computational intelligence. And when this computational intelligence is among a group, what I say, it is among a group of individuals. For example, we the humans, we the humans in the field of computational intelligence, suppose I know one algorithm, you know one algorithm, I say to you that algorithm, you say to me that algorithm. Now we know both the algorithms, right? We both become intelligent. So this is called the swarm intelligence. This is called the swarm intelligence. There is an author, Harari. I think you people may have heard of his name, Harari. Right now I'm reading a book by Yuval Noah Harari. The surname is Harari, actually. So that the brief history of the humankind, Sapiens, the brief history of the humankind I'm studying. So what the author, and that Harari is known as one of the most intelligent people on the earth, living human on the earth. He's the most intelligent. So what he said, that the humans are surviving because of the collective intelligence, because of the collective efforts. If the humans are living alone, individual, then they would not have survived on the earth till now. They are surviving because of the collective intelligence. And that collective intelligence, what is that collective intelligence? We all were inside the room, inside our homes. right? Inside our homes during this corona, and still we were continuing our education, our teaching, our jobs. The money was coming, my salary was coming, I was teaching, I would be able to, there were software engineers who developed immediately some softwares for online teaching. There were teachers who started to adopt this. There were students who started to adopt this situation. And we started to collaborate with each other. There are certain companies who started to deliver the, food items, grocery at the doorsteps. So, we humans helped each other. There were scientists who developed the medicine, who developed the vaccines. So ultimately we survived because we all were doing our jobs and we survived. This is called the swarm intelligence. When a group of individuals help each other to grow, to make themselves better with no central control. Nobody was controlling. Nobody was telling the scientists that you develop. This is your duty, otherwise we will kill you. Nobody was telling to the scientists that you will be shot dead if you will not develop the vaccine. But still, the scientists were doing day and night to develop this vaccine, medicine. Everybody was working their hard for the benefit of the society. That's why we are survived. It is called the swarm intelligence. When the individuals in a group work for the benefit of the society, of course for themselves also, in a collaborative manner, then it is called the swarm intelligence. The humans are not only surviving through swarm intelligence, not only the collective intelligence, not only the collaborative behavior. Among us, there is another behavior that is called the competitive behavior, evolutionary approach. We are competing also with each other. When there is a post of professor in a college, suppose in a college there is a post of one professor and 10 applicants, then what we will do? Everybody will come, everybody will study very hard to get that post, right? Just imagine another situation, one post, one applicant. What he will do? He will not make himself better. He said that, okay, I'm going to select tomorrow. There is nobody in front of me, right? So he will not make self, he will sleep very confidently. He will not make himself better. So through competition also, not only collaborative, through competition also we make ourselves better. And this approach is called the evolutionary approach, which is another category of the computational intelligence. So I explained you that computational intelligence, the society becomes better, the group of individuals become intelligent through collaboration, then it is called swarm intelligence. When the society become intelligent through competition with each other, then it is called the evolutionary competition. The population evolved, Darwinism principle, survival of the fittest. The third category is the artificial neural networks. When the individuals, how the human brain works, we develop the algorithms as per the human brain. This is the simulation of the human brain, a computer program which works like a human brain, and it is called artificial neural networks. Let me tell you, the deep learning is just an extension of the artificial neural networks. Okay, so the another formal definition, if I want to tell you of this swarm intelligence, then I tell you that it is the emergent collective intelligence of the groups of simple agents. Means when a simple agents behave in a group collectively, and then an intelligence emerges. Look, it was not inherent intelligence, it emerges, and this emerged intelligence is known as the swarm intelligence. There are many algorithms, thousands of the algorithms. Let me tell you, thousands of the algorithms are in the category of swarm intelligence. I cannot name all, and all are not that much different also. Of course, all are different means there are minor differences every algorithm has, but not significantly different. What the two algorithms I found the most important in this category are these two. Let me tell you, this particle swarm optimization and ant colony optimization. In 1992, this algorithm was proposed, and in 1995, this algorithm was proposed. 80% market in the industry where the swarm intelligence is used, for example, in robotics, in drones, in automatic, warehouse. Amazon warehouse is using swarm intelligence like anything. So there 80% times either particle swarm optimization is used or the ant colony optimization is used, right? However, because these were the oldest algorithm in this category, that's why they are more popular in the industry. Of course, other algorithms are also efficient. This spider monkey optimization algorithm we proposed in 2014. Myself, my 2 PhD students who are now professors, and 1 French scientist, Maurice Clark. So 4 people proposed this in 2014. It is inspired by the foraging behavior of monkeys, spider monkeys, who live in the deep forest. I'll speak on this. Artificial bee colony algorithm is another very good algorithm in this category, which is inspired by the foraging behavior of honeybees. Okay, evolutionary computation, as I told you, is based on the Darwinism principle of the survival of the fittest. You know, what happens in the evolutionary computation, what happens, a population is there. In the population, the 2 members, 2 individuals, we call them individuals, meet, right? They meet together. It is called the natural selection of the meeting, right? They meet, it is, and this meeting is called the, you may call it recombination, or you may call it crossover, right? So they meet, and then they produce 2 offsprings, 2 children, right? 2 children, they produce 2 children. Now there are a total 4 population, 2 and 2, right? So out of this total 4 population, the space is only for 2. So the 2 has to die out, right? So now there is a competition among these 4 members. And out of these 4 members, best 2 will survive. Now this selection, best 2 or some second best and third best, we will select. It is called the selection, again the natural selection. So they will survive, and then there is a minor mutation, minor changes in that particular individual also, which is not inspired by other members, which is in itself. You know, I belong to a business family. You know, in my family, everybody does the business. And this is a mutation. I am a mutation in my family who is into the job, who is into education. So, you know, sometimes individuals make a minor changes in their in themselves also. This is called the mutation. So these are the operators in evolutionary computation which can make a population intelligent over the iterations, iteration and iteration. Then the population can become intelligent. Again, I tell you that many algorithms are in the category of evolutionary computation. Genetic algorithms is the one most popular algorithm in this category, and it is inspired by, of course, the survival of the fittest. Same differential evolution is another algorithm in this category. However, differential evolution is not purely an evolutionary algorithm. Actually, you know, since evolutionary operators are used here, that's why we put it in the category of evolutionary computation, but it has nothing with that much with the evolutionary computation approach. It is more mathematical algorithm, right? Based on the differentials of the solutions, it is based, right? That's why, but the operators are evolutionary operators, so we put it in the category of evolutionary. Biogeography based optimization is a very recent addition in this category. In 2008, people have proposed, one US scientist, Dan Simon, proposed this algorithm. It's doing very good. So now, since time is limited to me, I'm not explaining you the algorithms motivation, but just quickly going through, and we'll just say about some application of this, possible application of this. So spider monkey optimization algorithm is there, which is inspired by the foraging behavior of spider monkeys. It is by the flocking behavior of birds. PSO is inspired by the flocking behavior of birds. ABC is by the foraging behavior of honeybees. Ant colony optimization is by the foraging behavior of ants in a colony. How ants can find the shortest path out of many paths. So they just deposit a pheromone, and ants follow the highest concentration of the pheromone, and this pheromone evaporates with time. So longer path will have more evaporation, shorter path have less evaporation, more concentration. So ultimately, after few iterations, only the shortest path will remain. Let me tell you, robotic path planning problem, discrete optimization problem, ant colony optimization is one of the top choice. Biogeography based optimization is based on the migration of a species from one island to another island. GA, I already told you, the encoding, selection, crossover, mutation, elitism are the operators. I just want to share one very interesting application of the swarm intelligence, that is the drone swarms. Just see this video. It's a very small video. 10-15 second video. Look at the drones. They took off parallelly. They started moving by making consensus with each other. And let me tell you, nobody is flying them. There is no remote control. It is an autonomous system. It's a complete autonomous system. Now, how this autonomous system can behave, of course, apart from other aerodynamics, electronics, and vision computing, apart from all those algorithms, swarm intelligence is also very important algorithm in this, where the swarm intelligence algorithm is going to decide how they should communicate with each other, so that with minimum number of communications, because if the networks are too many, if the communication is too many, then a lot of information processing is to be done on the onboard computer. And let me tell you, this onboard computer is very small computer. Its power is not much, right? So and they have to take decision also very quickly, because they are around 10 to 15 meters apart, and they are flying at the speed of around 14 meters per second. Just imagine, if the processing time is delayed by 1 second, they will collapse, right? So we need a quick calculation and quick decision accordingly, right? So the information processing on one onboard computer should be as less as possible, and the decision should be in such a way that they can decide where my other friends are and where my other friends are moving, right? So everything is done by themselves independently without colliding with each other. So how to decide this topology, communication topology? Swarm intelligence is helping into this, right? And it's very, very good paper. I mentioned it here at the bottom, you can see. This is one of the top application in the railways, not Indian Railways, Japan Railways. This is your first figure. This is bullet train, Shinkansen N700 bullet train. This aerodynamic shape is the genetic algorithm, designed by genetic algorithm. And let me tell you, this is the best design till now. Nobody can found better than genetic algorithms design. No algorithm they can found better than genetic algorithm till now. This optimal location of the wind turbines, biogeography based optimization. I also solved this problem. I found the biogeography optimization is giving the best results in this category. So what I want to say you that if you have a problem, model it as an optimization problem, develop the algorithm inspired from the nature, swarm intelligence, evolutionary, or the neural networks based. Do it hardware implementation, you have a complete solution. There are many areas where you can think of working in the field of computational intelligence. You can develop some parallel variants of NIA algorithms, multi-objective variants of design new algorithm, find out new problems where you can apply these algorithms. So if you are a computer scientist, you can think more on artificial neural network based algorithm, ANN based algorithms. Of course, into this also, if you are a mathematics person, then I strongly recommend that you come to swarm intelligence or the evolutionary computation. Enough scope is there of your mathematical skills to explore for the development of these algorithms. If you are an engineer, of course, you are most welcome in all the kind of algorithms, because you are the person who is to decide that where these algorithms are to be applied in future and can make their name. So no-frill-lunch theorem says that no algorithm is the final algorithm. There is always an improvement, chance for improvement. So keep doing the work, keep doing the research, you will have a better solution, better algorithm. At last, I say that the best artificial intelligence algorithms these days is the computational intelligence. And out of the computational intelligence, personally, I feel that swarm intelligence is a good approach, is the best approach. Thank you so much. I'm okay to take the questions now. I hope I finished in time.
Yeah, thank you so much, sir. There is one question.
Yeah.
So you are talking about artificial intelligence and its specific categories, whereas developing such intelligence by having inspiration from natural intelligence. So my query is, don't you think that in future machines might be more intelligent due to iterative learning and thus might spoil the natural thought process of human? The big
It's
question.
a very, very interesting question, and it's a debatable question. In fact, it's a discussion. It's not a question, it's a discussion. So my answer is neither yes, neither no. Again, I want to refer that book just because right now I'm reading that book. So I'm again and again, I'm taking the example. There is another book by the same Harari, 21 Lessons for the 21st Century. There the Harari said that in the future, the human will itself be a machine. Human will itself be a machine. What does it mean? That, the almost all kind of challenges are over now. What are the main challenges for the human beings? The food that we are now we are now comfortable with the food. We have enough technology that we will not die by hunger, right? We will have enough technology to feed ourselves. So food, and then the war. The second other problem is the war. So, nowadays, many countries, collaborations are there. So they are trying their best not to have another war. Now, next challenge is the death. So now the scientists are working to overcome the death of the human being. And yes, it may be possible. The Harari said that yes, it may be possible in future, because death means certain parts of the body are declining. So the machines can replace that part. If my liver is gone, there will be a artificial liver who will be inserted to me. If my hand is not there, new hand will be there. If my eyes are not there, or my eyes are weak, new eyes will be there. Machine eyes are there. So actually in future, the human itself will be a machine. So I don't think that there will be a threat from the machines to humans, because ultimately cognitive intelligence is coming from the human. Whatever the machine know, the trained by the humans, and the cognitive decisions are to be taken by the humans only. And machines cannot take. Machines can take the decision only based on the data, whatever is feeded to that. Now it is up to the humans that they should not make themselves weaker. For example, we are on the path of making ourselves weaker. Nowadays, what is happening? We rarely, think of finding a solution through books. I'm into my university from last 10 years. This is my 10th year going on in my university. I never went to a library of my university. I never seen, actually. I don't have the membership of my university library. Can you imagine this? Because all these resources are available online. Whenever I need anything, I take printout, right? What is happening? Whenever there is a question in me, I just Google it. I never try to find out the books. I never try to read that. If there is any calculation, being a mathematics student, even I don't try to do that calculation manually. I always seek calculator. And now this calculator is so easy in mobile also. So my calculation power is declining day by day. Everybody's, not mine, everybody's. My next generation, they will start declining cognitive knowledge, right? Once we will start declining cognitive knowledge, of course, machine will start ruling us. Now it is up to the human that if they will not decline themselves cognitively, right? Then of course we will rule them, because ultimately we are the masters. They are not the master. Machines are not the masters. This is up to us that we let them to be the master or not. Right. So my answer is, neither yes nor no. It is depending upon us that what the future generation will decide, that they want to be the slave of the machines or they want to be the master of the machines. Right. And this is in fact, within the 21st century, we have to decide that how we want the 22nd century. Yeah. And book for the swarm area, swarm intelligence. So I cannot name only one one book, but there is a very famous book, Computational Intelligence by Andres Engelbrecht. Let me type the name, Andres. I'm a fan of this book, Andres Engelbrecht. The book is Computational Intelligence. You may online available. It's soft copy is also online available. It's very costly book, but soft copy is available. You can just Google and can find this book. It's a very good book. Swarm intelligence based algorithm, neural network based algorithms, evolutionary computation based algorithms are there in this book. If not comfortable with this book, of course, you can Google my web page. I have uploaded some videos, some lecture notes there. You can go through that. Or I also have one book, Evolutionary and Swarm Intelligence. This is my book. You can Google it, or you can drop an email. I can send the soft copy.
Thank you, sir. Since we have time restrictions, participants who have some queries, they can mail us their questions and we will forward it to sir. Thank you once again, sir. The information you shared on computational intelligence was very enlightening for all of us. Thank you once again for being a part of this session.
Thank you, madam. Thank you so much. Thank you so much.
Moving on, I wish to extend a warm welcome to our next speaker, Professor Manish K. Gupta. He is a professor at Dhirubhai Ambani Institute of Information and Communication Technology, Gandhinagar, Gujarat. He has an international and interdisciplinary working experience of more than 28 years in 8 countries. He is the founder of Dhirubhai Ambani Institute of Information and Communication Technology, Center of Entrepreneurship and Incubation, and also the founder of Gupta Lab. He is a senior member of IEEE and has supervised 3 PhDs, 51 undergraduate research projects, and more than 200 summer interns. He has published several research papers in reputed international journals and has published several books. His research areas include mathematics and its elegant applications in emerging technology, namely DNA and bacterial data storage, DNA computing, chemical computing, coding theory, cryptography, DNA nanotechnology, and many others. Once again, I welcome you, sir, to speak on the topic, how to store elephants. Now I request Professor Gupta to please begin the session.
Sure. Thank you. And thanks to the organizer and principal madam and all other organizer or people in the organizing team. I think this is a time around 6:20, so maybe some of you might be feeling hungry for the dinner, right? But I hope before dinner, in the next 30 minutes or so, I'm going to give you some beautiful ideas about how mathematics, computer science, and biology, they interact in an elegant way, so let me share my screen, I guess, first. Can you confirm that if you can see my screen?
Yes, sir, it is visible.
Good. So the title of my talk is How to Store Elephants. So, 1 minute. Can I minimize this? I'm not sure if. Yes. So how to store elephants? So elephants, you can see, the answer to this question is you can store elephants on the elephants itself, or maybe in the gut bacteria, So what does that mean? Basically, that these elephants are made out of DNA, and so DNA can, is a recipe for making the elephants, and you can, look at their genome, and you can store that genome on the bacterial genome or some other places, in the genome itself. So there's a nice intersection of these things. So essentially, over the last 20 years, I would say, a lot of happening is going on at the intersection of biology and computer science. So we say that life and computation are related. I mean, this is a quote by Edelman, who was a famous cryptographer and who is also the founder of DNA computing. He says that life and computation are related, and I'm confident that at their interface, great discoveries await those who seek them. And believe me, there are plenty of opportunities available for any mathematician, computer science person, or any engineer. In fact, you pick up any branch and you see there is something analogous already there in the biology. So biology is the science of 21st century, and each of us should look at biology. As, in fact, in the previous lecture, as you saw, that most of the algorithms like swarm optimization and other things, they are taking inspiration from biology itself. All these things are there in biology, or and in fact, I just wanted to mention that our group has developed a software, AntSoft, where you can use real ants to do any computation. So we have the software, which using that software you can do that. People have done this experiment where they have taken 10,000 real ants to solve a to solve as a problem in mathematics. So it's a really interesting thing. So let me show you a few more things. Now I'm going to talk about the area of DNA computing, which is a part of biomolecular computing. So biomolecular computing has theoretical areas like membrane computing, peptide computing, bacterial computing, DNA computing, and RNA computing. However, people are more focusing on DNA computing, bacterial computing, and RNA computing, because these are more, applications are possible in these three areas. So now, what is DNA computing? So computing using DNA strands. So DNA is, as you know, it is in each of us are having our own DNA, right, genome. So it's nothing but you can think of simply a string of ACGT, right? So something like this. I'll just show you here. So for example, you can see this is a string of ACGT. This is also a string of ACGT. This is DNA. So any computation problem, what we do in the classical computer, we take a computation problem, we input into the computer, and then there are binary operations in the form of circuits, and the output is in the form of binary strings. So you can solve the problem, and you can go back from binary string to the actual solution. Now, in case of DNA computing, we encode problem into these DNA strings of ACGT, DNA strands, and then the operation is run in a test tube, and output is also in the form of DNA strands. So you read them back, and so you look at the solution. So Edelman did the first experiment in 1994, where he solved traveling salesman problem using DNA computing, and that was a seminal paper in Science. And since then, a lot of work has been done in this area. Now, plenty of applications areas are there, like DNA tiles, DNA nanostructures, DNA cryptography, DNA strand displacement, DNA circuits. I'm going to focus on DNA data storage system. So what is DNA data storage system? Let me explain to you. Now, storage is a fundamental need for both life and computation, and every life needs storage. Storage of resources such as food. Storage is also basic computing primitive. And one can say that what is life? Life is nothing but storage plus information processing or computing out of it. Now, modern humans stores data, and if you look at the nature, there are plenty of nice examples like these honeypot ants. They store honey actually. Okay, so it's a very common thing in nature, And humans have done a lot of experiments with different things, starting from cave paintings, stylistics, papyrus, paper, punch card, hard disk, RAM, floppy disk, magnetic tapes, CD-ROM, DVD, compact flash, memory stick, and finally, these days we store data in cloud data storage. For example, that in the Gmail, each of your file is decomposed into certain packets, and those packets are replicated into the cloud. And whenever you access the cloud, you are able to recover the file, using some mathematical algorithms. So this is the scenario of the current storage. So what is the big deal actually? What about elephants? So my talk is about elephants. So what do you mean by elephant here? Elephant means big data. So we are generating data every day. So how much data we are generating? Let me give you a brief snapshot of that. So there is a nice estimate by Eric Schmidt, who was the former executive chairman of Google. On August 4, 2010, he gave this estimate. How many elephants are we generating now? From the dawn of civilization until 2003, humankind generated 5 exabytes of data. 1 exabyte is equal to 1 billion gigabytes. So basically, exabyte is in the order of 10 raised to power 18, okay, of data. And now we produce 5 exabytes every 2 days, and the pace is accelerating. So this is the scenario back in 2003, in 2010 actually. 2010, this was a scenario that every 5 exabytes are generated every 2 days. So in fact, you can look at the internet. What is the current size of internet? It is something in the order of 700 exabytes, exabytes. So basically in the order of 10 is for 18. So this is the size of the internet. Still we are generating a couple of exabytes every day. So this is the pace at which we are generating the data. So what if so basically we are using Facebook, doing all kind of things, YouTube videos, Google searches, Netflix, Uber rides, App Store, Amazon, everywhere we are just generating data. Now in 60 seconds, this is a snapshot of what will happen. So in the future, we know that Internet of Things is happening now. Means each device, maybe your fridge is having an internet address, IP address, or other small electronic devices have IP addresses, and they interact with each other. So people are saying that we will generate data in the order of 10 to the power 30. So which is huge amount, right? So so new vocabularies: megabyte, gigabyte, terabyte, petabyte, exabyte, 10 to the power 80, zettabyte, yottabyte, nontobyte, and zipobyte, which is 10 to the power 30. Now one can ask this question. So okay, fine, we are generating this much data. So what is the problem? The problem is the following. There are two problems. First is space, and another one is the cost. So here is a nice estimate given in 2008. So how big is the yottabyte? So 1 terabyte you can store in just like hard disk. Petabyte is this kind of storage pods. Exabyte will require approximately 2,000 cabinets and fill a 4-story data center that take up a city block in US. Zettabyte will take 1,000 data centers, or about 20% of Manhattan, New York. And yottabyte will fill the states of Delaware and Rhode Island with millions of data centers. So space requirement is too huge. And if you compare the cost, so in 2008, you can see that US GDP was $14 trillion. European GDP was $18 trillion. World GDP was $61 trillion. And in 2008, the cost of storing 1 yottabyte data is $100 trillion. So it's a huge cost, right? Of course, the cost has reduced recently, but still it is quite big actually. So if you do the new calculations, one can see that is still there's a lot of money actually to store this much amount of data. So what is the ultimate storage device? Again, we look at the nature, and nature has given us a very nice thing, is DNA. You should note that 1 gram of DNA can store 455 exabytes of data. 455 exabytes of data. That means your 2 gram of DNA will be enough to store around your entire internet. Okay, so this is a great, great actually in terms of space, and probably 1 kilogram of DNA will be sufficient to store entire information ever produced on this planet. It's a huge density, So this problem is solved in terms of space requirement. Of course, there is still challenge with respect to the cost, and people are developing new algorithm, new technology in terms of DNA synthesis, DNA sequencing machines, and people hope that in future, probably next 5 to 10 years, we will have DNA storage devices which will cost you $25 per terabyte at that range, within 5 to 10 years. So what is DNA? DNA is, you can see there's a double helical molecule, double helix. So ACGT, adenine, cytosine, guanine, thymine. So, and they are, hybridized. So hybridization happens between A and T. There are 2 hydrogen bonds. Between C and G, there are 3 hydrogen bonds, right? You can see that. So, and there is sugar phosphate backbone, and if you heat them, so they will separate into single strand DNA. So we store data on this, using the technique known as DNA synthesis. Okay, so DNA synthesis machines are there, which can actually synthesize the DNA. Twist Biosciences in San Francisco is one of the great company which is developing a lot of new technologies for DNA synthesis. Okay, and so it's a writing process. You write the data, and then DNA sequencing you read. In fact, there is a Oxford nanopore mechanism is there, a sequencing mechanism is there. So which is just like pen drive kind of thing, where you can use this kind of machine for reading the DNA. So read process is really very well designed now. We need to worry about the right process, and of course the Statistical Biosciences is working a lot in this area. So what you do, how do you encode in the next 10 minutes, I'm going to show you how we do this encoding and decoding in the DNA. So you know your files, whatever your PDF, doc, or any your Facebook memories, whatever is there, that can be converted into, so that is nothing but you can easily convert into byte strings. Byte strings, so byte strings are strings of 0 and 1. And those things we need some sort of encoding to convert into ACGT. Then we use these DNA synthesis machine to convert into test tube material, and you store into test tubes, retrieve the test tube, do the sequencing, read them, and you from the software can read back to your binary file. This is how the data encoding and decoding happens. There are errors that happen. So error correcting codes or coding theory plays a very important role here. Reading errors, writing errors, storage errors. I will show you in one of the technique that we used, a Gole code, if some of you are familiar with coding theory, which is used to reduce the errors in DNA storage. This is our work that we have done in 2013. So we have developed a software, DNA Cloud, in 2013. So you can use the software to store your memories of Facebook memories right now. This software is available to download from our homepage, and guptalab.org/DNA Cloud, and you can actually use the software to store your memories. So there's a lot of some early work in 1999, and 2000, 2003, 2007, people have done some small experiments for DNA storage. So main paper is 2012 when George Church at Harvard, they have done the experiment of storing data into DNA. And later on, Nick Goldman, Emil, who is the founder of Statistical Biosciences, they have actually done the experiments for storing data again on DNA, and this time with improved error correction mechanisms. So they have the error correction mechanism in 2013. Okay, and then after that, many more papers. So right now there are a lot of papers in this area since last 7 or 8, 9 or 10 years. Let me show you. These are some initial papers, in the area, and so let me give you a brief example how it works. So the first Church model was, they used run length encoding, and DNA coding was there, and this was the chunk architecture that they used, and they stored 5.27 MB of book, in this paper. And later on, Goldman used this architecture. They used Huffman encoding, and finally we modified this Huffman encoding to actually come up with the nice thing here. So we implemented this software, DNA Cloud. We modified the algorithm of Goldman, and this was the nice work done by my BTech student Shalin Shah and PhD student Dikshita. So I'll just explain to you briefly what we have done. So we have stored data. So I think the previous work was in petabyte order, and we have stored data in exabytes. So this was a great improvement in terms of storage, that you can store in exabyte order using our software, and algorithms. This is the code that we used actually. It's a subcode of the Gole code, and this is the chunk architecture. Let me explain the trick actually. So here is how I am skipping this technical details, but let me give you. Yeah, so here is it, the word DICT. The ASCII values, we take ASCII values of the letters, then we convert using that table of ternary code words of ACG of binary, and then from this binary we look at the separator, extension, file size. We do the encoding in terms of ternary Gole code from ASCII, and then we convert we find a string like this, then actually after that we convert it into, this is the important part, we convert this string into the string of ACGT using this map. So you see that the first entry here is 0. So what we do, we look at 0, previous nucleotide is A, so C will come here, right? So C is there. Then next we go to 2, then we have the 2 here, and the previous nucleotide is C, so A will come here. So A is here, the next one. Like that, using this table, we actually convert the whole ternary string into ACGT of the DNA. Okay, and moreover, this mapping ensures that there is no repetition of ACGT, because if repetition is there, chances of error increases. So we have actually controlled that using this mapping. So this is discovered by Goldman, and we have modified this map further. Actually, you can find our papers if you want to really look at the mathematical portion of it. So, so this is how we get the final string. Then we divide it into chunks of length 99. Okay, and then we add headers. So we are indexing the chunk. So basically, we chunk 1, we add this header, or this kind of header is there, and then chunk 2, this kind of header is there. So we attach towards the end. Okay, so these are the DNA chunks. And so we implemented this algorithm of improved one in this, again published in another paper, the second version of the DNA cloud software. And you can see that this was the Nick Goldman paper, and we have significant improvement in terms of the amount of DNA needed to store the files. These are the files: JPG file, MP3 file, all the PDF, text file, and we have the significant improvement in terms of storage. We have also gone further. I mean, we have stored data on bacteria actually. So bacterial-based data storage system we developed, and so now you can store data in your stomach actually. Using our software, you can use this software. We have also demonstrated our work to the Prime Minister of India and Prime Minister of Israel in January 2018, and now I can show you this. For example, this text. If you look at this text here. So let me show you, like this text is converted into ACGT like this. You see, Israel's India's ties for tomorrow is converted into this kind of text, right? If you go to the next one, this is the image. You can see image file will be a bit better in the DNA. In terms of DNA, image file is a little bit better. You see, a little bit bigger actually. This image is converted into DNA, right? So this is how we converted, audio. Video as well. You can see all the things are available on the page. It was also reported in Times of India in March 2018. Now I'll show you some towards the last, just a couple of minutes I will take more, where I will show you some recent news headlines. See, they have used living bacteria to store a movie. A movie is stored in living bacteria recently in 2017. Okay, this is the Microsoft prototype, $10,000 prototype. And they have demonstrated the writing of word hello, and it used approximately 1 milligram of DNA, and write and read took 21 hours in 2019. And after that, a lot of work is. This is the machine. So this, you see, initially it looks like quite bulky, but the vision is to have a pen drive kind of thing for the entire machine. And there are many companies which are working, especially as I mentioned, Twist Biosciences, Catalog, DNA Script. These are the main companies which are working. In fact, SRC is also doing a lot of work. There is a DNA Data Storage Alliance, International Alliance. We are also partner here in this alliance, where 33 member organizations are participating to create the technology. They have installed, Netflix show in the Twist DNA. So the challenge is still we need to go for 455 exabytes, developing new error correcting techniques, coding theory. Storing elephants is still costly. Rewritable DNA storage, a lot of work has been done recently. And also you can try other things like bacteria, plants, and this is how you store elephants. You see, initially, early days, CD contains these many papers. Now the test tube contains more information that exists on the earth in a small test tube, right? So this is the new. I'm thankful to my collaborators in this and the sponsors. And these are my students. I'm thankful to them who have done a lot of work in this. I think that's all. If you have any questions, by the way, I can ask you. You can subscribe to our YouTube channel. You can find a new course on natural computing where you can see how computer science and nature interact in a nice manner. So this link is given here. If you want, I can post it in the chat box as well. So if you have any questions, I will be happy to answer.
Thank you so much, sir. There is one question. Sir, shall this mapping from ternary to binary and invertible one? I mean, if the mapping is done practically with DNA sequence, can we retrieve original from modified one?
Yes, we can retrieve original from my modified one. Yeah, that's what our software has implemented that, and you can actually, it has been tested also. We have done the experiment as well, actually, using our software. So Yeah, so we have done the demonstration on both sides.
Are there any other questions? Thank you, sir, for imparting us knowledge in the field of DNA-based data storage. The talk was highly interesting and informative. Thank you once again for being a part of this session.
I think I can just give you the link of the software which you can use. There are 3 versions of it. 2 versions are available for installation. 3rd version is source code. So you need to compile the source code if you know Python, but and if you have any problems anywhere in the softwares, please do come back to us. So the thing is that right now you can use the software to store your memories in Facebook memories in the DNA. Send that Excel sheet that is output of our software to any biotech company, and they will send you a test tube with the data in the DNA inside your test tube, and you can store in your fridge or maybe in your garden, and you can get your memories 10,000 years after that, right? So that is possible.
Thank you so much, sir. On behalf of Department of Mathematics and IQAC of Mata Sundari College for Women, I would like to thank all the speakers, Professor Sadgupta, Dr. Jagdish Bansal, and Professor Manish K. Gupta, for taking out time from their busy schedules and imparting their knowledge to us. I thank all the participants for joining us today. Hope to see you all tomorrow. A special thanks to Professor Fulvio Zwani for joining us today. Thank you, everyone.
Please join tomorrow by 1:45. Our session tomorrow begins at 2 p.m. So tomorrow we will start day 2 at 2 p.m. So please all are requested to join by 1:45. Thank you. Thank you, Professor Gupta. Your talk was extremely interesting and enlightening. Never heard of all these things. So good to know new things.
So yeah, my email address I have also sent. If there are any questions, they can come back to me actually, or anything. Or if you want slides or anything else, I think talk is already available online, so that's okay. Yeah, thanks.
Yeah. All right. Thank you, sir.
Thank you.
Sonia ma'am, can I stop the live